Hey guys, so today we're going to be talking about Lewis structures, and Lewis structures are the visual representations of a compound, showing how the peripheral atoms are bonded to the main atoms with valence electrons. Just a couple things to note before we get started. The valence electrons are the total electrons represented in the structure. And so an example of this, we'll use H2O, water. So water, or hydrogen, H, has 1 valence E, and oxygen has 6 valence electrons. And so H2, because there is 2, so we do 1 times 2 from right here, and we get 2 total valence electrons. And then, like a V for valence electrons. And then oxygen just has a 1, so no subscript, so 1. So that just stays as 6 valence electrons, and it gives us a total of 8 valence E. So this means that there should be 8 total valence electrons accounted for in the structure. Another thing that would be worth for us to write down is the bonds are represented by lines, and the lone pairs are represented by dots. And when writing these, the easiest first step is going to be 1, the skeleton, and then second, the electrons. Okay, so that's basic understanding of Lewis structures. The valence electrons, number 1, bonds, lone pairs, which are represented in lines and dots, and then just the basic way to begin drawing a particular structure. So moving forward, it is very handy to have a periodic table when drawing Lewis structures, just so you can see the amount of valence electrons, and it's easier to kind of get an idea of how many electrons you'll be filling in. So now moving into octets. So there are 3 types of octets. There is the normal octet, which is made up of 8 electrons. There is a suboctet, which is less than, so we'll say less than 8 electrons. And then there's the superoctet, which is greater than 8. So, this is also something that's very important when representing a structure correctly, and you'll see that with our following examples. So, our first example, we'll do a plain normal octet. So we'll start with CO2. So the main atom in this is carbon, and the peripheral with our skeleton is oxygen. And you know the main element from the peripheral based on the electronegativity difference. So moving forward, C, carbon, as we look up into our periodic table, has 4 valence electrons, and oxygen has 6 valence electrons. So with that being said, we have 4 on carbon and 6 here. Because there's a subscript of 2, we will multiply this by 2 to equal 12 for the oxygen. So we have 12 and 4, 16. So we have 16 total valence electrons needed in this structure for the basic structure. So now we will fill in the dots. So we have 1, 2, 3, 4, 5, 6. So we have 2 here, 2 here, 2 here, and 2 here. That's 2, 4, 6, 8. So that octet is correct. And then let's fill in this side. And now, let me erase this and kind of draw this a little bit neater for us. Oh. And then we have our dots. Okay, so now what we need to do is count the dots and lines. Lines also represent 2 electrons apiece. So let's count. 2, 4, 6, 8, 10, 12, 14, 16. So we have 16 total electrons represented, but this is an incorrect Lewis structure because yes, the octets are correct on the oxygen, but the octets are not fulfilled on this carbon because we only have 2 and 4. So we will shift a lone pair from each side as a double bond. So we will get rid of that, and we will turn each of those into a line. And with that, our octets are complete, and all the octets are satisfied, and the molecule is finished. So this is the Lewis structure for CO2. Moving forward, now our next structure we will do boron trifluoride, BF3. So, let's start with our basic skeleton. B, 1, 2, 3, F, F, F. Okay, now let's get a count of what we're going to need here. So, boron is going to have 3 valence electrons, and fluorine is going to have 7 valence electrons. Because of the subscript of 3, we will multiply this by 3, and we will get 21 for fluorine. So 21 and 3 is 24 electrons total. Okay. So, moving now, let's fill in our dots. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. Okay. So now let's get a count. So we have 2, 4, 6, 8. 2, 4, 6, 8, 16, 18, 20, 22. We have 24 total electrons in this structure. So with that being said, you may think, let's add another bond here to complete the octet on boron. But boron is a special case here where it is a suboctet. So boron is satisfied with less than 8 total electrons around it. And this is because when you fill in boron, so say we have B, boron, and you fill in around it, its valence electrons. So we have 3 valence electrons, and we fill these in like this. 1, 2, 3. So this space right here is empty, meaning that it only needs 1, 2, 3, or 2, 4, 6 electrons to satisfy its sextet. So yeah, this is boron, and boron, that is the structure of boron trifluoride. Moving to our next and final structure we will practice on would be PCl5, phosphorus pentachloride. So, let's start with our basic structure, our skeleton, P, and then we have 1, 2, 3, 4, 5 Cl's in each of these. Okay, so let's go look at our periodic table now. So phosphorus has 5, and chlorine has 7. So phosphorus, we're going to have 5. Chlorine, we're going to have 7. Subscript of 5 equals 35. So 35 plus 5 is 40 total electrons. Okay, so right off the bat, looking at this, you might say there is more than just an octet around phosphorus, because we have 2, 4, 6, 8, and 10. So this is another special case. Phosphorus is considered in a superoctet, and what that means is, so phosphorus here again, we have 5. So if the central atom is an element for which the atomic number is at 15 or greater, then it has low-lying empty d orbitals, and these may contain up to 12 valence electrons. So this is okay at 10 because it is it's less than 12, and yeah, so 2, 4, 6, 8, that's 10 total around it. So let's fill in our dots now. Our dots will have 6 around each. Okay, so now let's count it all up. So we have 8, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40. 40 total. So with 40 electrons and all of these octets and superoctets satisfied, this is correct. So just to reiterate, just be sure of what elements you're working with, and if they're satisfied with an octet, suboctet, or superoctet. Be sure to count up all your valence electrons so that you correctly represent each structure. And make sure to just start slowly, draw your skeleton, count up your electrons, and then fill in the dots as needed to complete each octet. Thank you for watching, and I hope this helps.